In this video, I'm going to show you how I install DIN rail hardware and components the right way, so the panel is clean, reliable, and easy to service later. Whether I'm building a new control panel or adding to an existing enclosure, I'll go step by step so you can work confidently and safely. Here's what I'm going to cover. Arranging components on the backplate to determine the best location for the DIN rail. Placing the DIN rail and inserting grommets. Attaching the DIN rail to the backplate with screws and washers. 2 methods of grounding the DIN rail. Attaching components to the rail, starting with end caps and spacers. Wiring the DIN rail components. And removing a component from the DIN rail. If I'm working on an existing panel, I shut off and lock out power first. Then I verify with a multimeter that no voltage is present. Safety comes first, every time. First, I plan the layout. I set the components on the backplate in their approximate positions, so I can see how everything fits before I commit to any mounting holes. As I'm arranging things, I need to consider a few key factors. The first is wire routing. I want my components positioned so that wires can run cleanly and efficiently without crossing over each other unnecessarily. The second factor is clearance. I need to make sure there's enough space between component groups for heat dissipation and for safe, comfortable wiring access. The third factor is grouping things logically. I want to keep related components close together, so the finished panel is easy to read and troubleshoot. Once I'm happy with the layout, I insert grommets into the appropriate backplate holes for each component, then set the components aside. Doing the grommets now makes final installation faster and keeps the layout consistent. With the grommets in place, I'm ready to fasten the DIN rail to the backplate. I put a washer on each screw before driving it in. The washer spreads the clamping load across the grommet and the rail, helping prevent the screw head from pulling through over time. I start by driving each screw about halfway into its grommet. Once all screws are started, I go back and fully tighten them. Give the DIN rail a quick tug to verify it is securely mounted. It shouldn't move at all. If it flexes or shifts, I go back and check that all screws are fully seated and torqued down. Grounding the DIN rail is a critical step. Many DIN rail components use the DIN rail as a ground path. A properly grounded rail ensures any fault current has a safe path back to the source, which protects both the equipment and the people working on it. I'll show you 2 methods, and the one you choose will depend on your enclosure design and local electrical code requirements. The first method uses a short green ground wire to connect the DIN rail to a dedicated ground lug in the enclosure. I use this method when I want a clearly visible, inspectable ground connection, or when the enclosure design requires it. I strip both ends of a short length of green 18-gauge wire and crimp a ring terminal onto each end. I attach one end to a ground lug on the DIN rail and the other end to the main ground leg or ground bus in the enclosure. I make sure both connections are torqued to the manufacturer's specification. Verify the connection with a multimeter before moving on. The second method is a direct metal-to-metal connection. This is a good method when working with a painted or powder-coated backplate, because paint is an insulator and will prevent a good ground connection if not addressed. I select a spot where a solid section of the DIN rail overlaps a solid section of the backplate. Using the appropriate tap drill bit, I drill a hole through the DIN rail and the backplate. Then I install a ground screw into the tapped hole and tighten it firmly to ensure a low-resistance ground bond. This method depends on the backplate being properly grounded to chassis ground to complete the ground path. Again, I can verify the connection using a multimeter before continuing. Now I can populate the rail with components. I start at one end and work across in order. The first things I install are the end caps and DIN rail stoppers. End caps go on each end of the DIN rail to cover any sharp edges on the rail. Some DIN rails, like the rail in this video, are placed against the side of the enclosure and do not require the end cap. DIN rail stoppers sit between the end cap and the first component and lock the group in place, so nothing slides during installation or operation. I also use additional stoppers to separate different component groups. To attach a component, I hook the top of its mounting clip over the top edge of the DIN rail, then press the bottom of the component firmly toward the rail until I feel and hear the spring clip snap into place. For most components, hand pressure is all I need. For components with a stiffer spring clip, I use a small flathead screwdriver. I insert the tip of the screwdriver into the release slot on the bottom of the component's clip and lever it slightly outward. This opens the clip just enough to slip it over the bottom edge of the rail. I then release the screwdriver and the clip snaps shut. I'll continue installing components in sequence across the rail until all components are in place. Note how the components are separated into groups of similar connectors. This helps to keep the DIN rail organized and eases any troubleshooting that may be required at a later date. Each group has its own set of DIN rail stoppers to keep the components locked in place on the rail. Wiring the entire enclosure is beyond the scope of this video, but I do want to show how I attach wires to DIN rail components. Good wiring practice makes a panel that's functional, safe, reliable, and easy to maintain. I choose wire lengths that reach comfortably without tension, but I avoid unnecessary slack so the enclosure stays clean and the wire paths are easy to follow. Wire ends can be bare, tinned, or have a ferrule crimp on the ends. Using ferrules on stranded wire before inserting it into a terminal block is preferred. A ferrule is a small metal sleeve that is crimped over the stripped end of the wire. It keeps the strands together, prevents loose strands from causing shorts, and gives the terminal screw a solid surface to clamp against. Many DIN rail components have connections that require opening with a small flathead screwdriver or pin. Depress the connector mechanism with the screwdriver. While pressing on the mechanism, fully insert the end of the wire into the receptacle on the component. Remove the screwdriver and give the wire a slight tug to make sure it's anchored. Ensure the connector closed on the ferrule or bare wire, not the wire insulation. Other DIN rail components have the wire secured with a screw. Insert the ferrule or bare end of the wire into the terminal and fully tighten the terminal screw. Under-torquing can lead to loose connections that arc and overheat. Over-torquing can damage the terminal. As I wire each component, I route the wires neatly along the same path and secure them with cable ties at regular intervals. I label every wire at both ends using a label maker or pre-printed wire labels. Clear labeling is one of the most important things I can do to make future troubleshooting fast and straightforward. At some point, I may need to remove a component from the rail, whether to replace it, troubleshoot it, or reconfigure the panel layout. Here is how to do it cleanly without damaging the component or the rail. First, and I cannot stress this enough, cut power to the panel and verify with a multimeter that no voltage is present before touching anything. Then I disconnect the wiring from the component terminals. To release the component, I locate the spring clip release slot on the bottom of the component. It's usually a small rectangular notch or slot. I insert the tip of a flathead screwdriver into that slot and lever it downward or outward depending on the component. This releases the component grip on the bottom edge of the rail. While holding the clip open with the screwdriver, I tilt the bottom of the component away from the rail, then lift it up and off the top edge. The component comes free cleanly, without forcing or prying. I always set removed components aside carefully so I don't lose any associated hardware, and I know the original wiring connections before I disconnect anything. And that's the process of installing DIN rail components from start to finish. Let me do a quick recap of the 5 things I want you to take away from this video. Always plan the layout before attaching the DIN rail and first component. A little time spent arranging components up front saves a lot of rework later. Ground your DIN rail every single time, And always verify that ground connection with a multimeter. Use ferrules on stranded wire when possible. It is a small step that makes a big difference in connection quality and long-term reliability. Torque the terminal screws to spec. Too loose and too tight are both problems. Label everything. Your future self and anyone else who works on this panel will thank you. If this video was helpful, please like and subscribe for more tutorials. If you have questions, contact Campbell Scientific. We're happy to help. Thanks for watching.